Sir, good evening, sir. Issue Rao, sir. Sorry for creating issues. Sir, login, sir. Login, sir. Now, with the existing participants, we'll start the session. Our all the participants, very good evening. Hearty welcome to 1 week online AICTE ATAL Faculty Development Program, sponsored by AICTE and ATAL. Recent trends in high performance computing using AI, organized by the Department of Computer Science Engineering, Bonu Venkatchalme Institute of Technology and Science, Amlapuram, Andhra Pradesh. It's my privilege to invite all the dignitaries to this wonderful FDP organized by Department of Computer Science Engineering with the great support of AICTE ATAL. For college management, Sri Bonam Kanakai Garu, Secretary and Correspondent, Sri Bonam Krishna Satish Garu, Chairman of BBC Group of Institutions, our college principal, Dr. JVC Ramarao Garu, our college principal, Dr. JVC Ramarao Garu, Vice Principal, Dr. MCS Madan Garu, all the head of the departments of both UG and PG programs, Principal VVC ITS, Polytechnic College, and administrative officers, and everyone to reach this online workshop from application to materializing this state. I am inviting the great resource persons, Dr. V.C.V. Rao, sir, Dr. SSSN Usha Devi Madam, Assistant Professor of Computer Science, JNTU College of Engineering, and panelist of high performance computing experts by AICTE. I am thankful to everyone. Because of less time, I am unable to express everyone. So, first of all, for your great patience, thank you very much. Due to some technical issue using this WebEx, I am unable to start the session in time. So, I invite cordially for this 6 days online workshop from Bonu Venkatchalme Institute of Technology, Computer Science Engineering. Principal I request our principal sir, Dr. JVC Ramarao Garu, to give his valuable address to the participants. And for this workshop, Dr. M.H.M. Krishna Prasad Garu helped a lot for providing resource persons and guiding me. A warm welcome to Sir Swarup, sir. Have you joined, sir? Any issue? Okay, sir. Thank you, sir. Thank you. Principal sir, join. Sir, good evening, sir. Sir, principal sir, very good evening, sir.
Is that all participants are ready, sir?
Yes, sir. Yes, sir. Everyone is ready, sir. Very good evening, sir. Warm welcome to our online 6 days ATAL FDP on high performance computing using artificial intelligence, sponsored by AICTE ATAL and organizing by Department of Computer Science Engineering, Department of CSC. I am thankful to all the resource persons, such as Swarup sir, CDAC expert, in high performance computing, Dr. VCV Rao sir, Dr. Usha Devi madam, Dr. KVD Kiran sir, Dr. MHM Krishna Prasad sir, and other courses experts and industry experts and all the participants. Warm welcome to this online 6 days workshop, FDP. I request our Honorable Principal, Dr. JVC Ramarao Garu, to give a brief address about this ATAL FDP, sir. Thank you, sir.
Thank you, Dr. Srinivas. Good evening, honorable guests, participants, faculty members. It is with a great pride and enthusiasm that I welcome you all to this online FDP on high performance computing using AI. This was organized by the Department of Computer Science Engineering, BBC Institute of Technology and Science. Actually, the faculty members basically are the backbone for any educational institution. The quality of education that students are receiving is directly influenced by the dedication and expertise and innovation of their teachers. In today rapidly evolving academic and technological landscape, it is very imperative that we as educators to adopt new technologies, methodologies, and emerging trends, innovative practices in the education system. I extend my heartfelt gratitude to the distinguished speakers, resource persons, and organizers who have made this program possible. And I officially declare the FDP open, and I wish you all the best and enriching and insightful learning experience. And once again, thank you for being part of this ATAL FDP organized by the BBC Institute of Technology and Science, Department of Computer Science Engineering. Thank you for all attendees. Thank you, sir. Sir, మీ
Thank you,
mute
sir.
లో ఉంది.
Yes, sir.
Yeah.
Yes, sir. Yes, sir. Thank you, sir. Thank you very much for your wonderful words about our ATAL FDP in our
Yeah.
BBC Institute of Technology and Science. Now, as delayed, a brief report about the Department of CSC, Department of Computer Science and Engineering, established in 2002 with the intake of 60. Later on, increased it to 90. Now it is running with 180 intake. Department of CSC is offering MTech program is also, and the Department of CSC is accredited by the National Board of Accreditation for 3 years from 2023 to 2026. And the key asset of our department is the experienced faculty, highly talented students with very good placements. And our institute, Bonu Venkatachalama Institute of Technology and Science, established in heart of the Konaseema district in Andhra Pradesh state. So, because of lack of time, I am not unveiling more details about our institute. Now, about the ATAL FDP, a brief report about our ATAL FDP. ATAL FDP applied with the title of recent trends in high performance computing using AI. Now, high performance computing plays a key role in all applications related to the AI, and AI changed every computation and software and everything make tremendous changes. The impact of artificial intelligence and their tools in high performance computing we have taken as a thrust area for our faculty development program. And for our program, approximately 160 participants enrolled. Now on board is also approximately 100 people are there, even though due to technical issue it is unable to start in time. I'm thankful to the patients and for your patience and wonderful support by the participants as well as resource persons, especially Dr. VCV Rao sir and Dr. Satya Swaroop sir from CDEC Pune, Param Supercomputer Division, National Supercomputing Application Mission Consultant people, and Dr. Usha Devi Madam from JNTU Kakinada, and Dr. M.H.M. Krishna Prasad sir. He is has extended a great support to realize this workshop. Actually, the CDEC experts given by his reference only. I'm very much thankful to our management and our principals are continuously encouraged to realize this workshop materialized, and with his encouragement only we are able to apply and getting the opportunity to conduct this wonderful workshop for the benefit of faculty overall India. I'm thankful to all the participants and research scholars overall India. Thank you very much. Now I request today's chief guest, Dr. VCV Rao sir, and I request VCV Rao sir to give a brief note about today's workshop as a chief guest for this inauguration function, sir. Sir, VCV Rao sir. Sir, please give some keynote from portal, sir.
I'm now on the connectivity, but I'm able to see a couple of people, but I'm not able. Can you able to hear me now?
You are not there, sir?
I'm there. I'm able to see all of you, but are you able to hear me?
No, sir. No, sir.
Actually, all are in line, but
Yes,
few
sir.
people are appearing.
Yes, sir.
See,
You are there, sir. You are there, sir. Please, give your message, sir.
can I speak now?
Yes, sir.
Some resource coming now?
No, sir. No, sir. Sir, you can start, sir. Hello, VCV Rao, sir. పెట్టేనా అలాగే హలో సార్ ఇప్పుడు స్టార్ట్ అయింది సార్ జస్ట్ సార్ అంటే ఎఫ్డి ఓకే పాస్వర్డ్ అయితే అటల్ ఎఫ్డి పైన చేయండి సార్ ఒకసారి Yes, sir. You are not. Yes, sir. You are not visible, sir. Yes, sir. Yes, sir.
Thank you very
Yes, sir.
much. Department,
Our receiver officer addressing keynote from mobile. Sir, please provide, sir. Yes, sir.
thank you very much for giving this opportunity. And it's a very good program where we require huge computing. The computing is nothing but high performance computing. And then the faculty member, principal, HOD, and everybody took this initiative. This initiative will bring young generation of students to think more about artificial how it can be applied to any application. This 4 to 5 days activity program is really beneficial to the faculty members and students, as well as the invited speakers, interact with many participants. In near future, high performance computing, one of the strong pillars of artificial intelligence. I wish this Friday program a great success, and I sincerely thank principal,
Vijay Kumar madam, ready?
academic department, faculty members for investing good amount of time to initiate this kind of finding. And I wish all the participants I thank HOD and principal for giving me this opportunity. So the workshop now, the 5 days program is open, and students can really interact. And I wish all of them in the FTP program. Thank you very much, sir.
Thank you, sir. Thank you very much for your valuable keynote on high performance computing. Now, vote of thanks by our co-coordinator, Sri Dr. D. Anurag.
Thank you, sir. Thank you very much. Good evening, everyone. It's my honor and privilege to propose the vote of thanks on this momentous occasion, the inaugural session of our faculty development program, Recent Trends in High Performance Computing Using AI, sponsored by ATAL. First and foremost, I would like to express my sincere gratitude to ATAL for selecting our online faculty development program. And I would like to express my deepest gratitude to our esteemed chief guest, Dr. VCV Rao Garu, for taking out time out of their busy schedule to grace this event with their presence and enlightening words. I extend my sincere appreciation to our management, Bonam Venkatachalama Institute of Technology and Science, and our respected principal, Dr. JVG Ramarao Garu, our HOD, Dr. K. Srinivas Garu, AO J. Krishnarao Garu, for continuous support vision and commitment towards this faculty development program and academic excellence. A special thanks to all our resource persons and speakers who will be guiding us throughout this FDP, and we are eager to learn from your knowledge. I also want to acknowledge the department faculty members for their relentless efforts in planning and executing this event seamlessly. A big thank to all faculty participants who have joined us for learning this journey. We hope this FDP will be a meaningful experience for you all. Once again, I thank for all your valuable time and support. Looking forward to an enriching and engaging FDP ahead. Thanking you, sir. Thanking you.
The first technical session will be started by Dr. SSN Usha Devi Madam. Before that, I request Mrs. G. Vijay Kumari, Senior Faculty of our Computer Science Engineering. Request to mention a brief profile of Dr. SSN Usha Devi Madam. Vijay Kumari Madam, please.
Yes, sir. Yes, sir. Good evening, everyone. Myself, Vijay Kumari, associated with the Department of CSC, VVCITS. It's my privilege to welcome you all to the first session of Faculty Development Program on recent trends in high-performance computing using artificial intelligence. We are honored to have an esteemed expert with us today, Dr. SSN Usha Devi Ma'am, who will be sharing her valuable insights on fundamentals of HPC. Let me present you the profile of Usha Devi Ma'am. Dr. SSN Usha Devi Ma'am holds a PhD from NIT Trichy in the area of deep learning, an MTech in Computer Science and Engineering from the University College of Engineering, JNTU, Kakinada, a BTech in CSE from JNTU, Hyderabad. With an excellent publication record, she has authored 66 articles in international journals and conferences and published 6 textbooks focused on artificial intelligence. Dr. Usha Devi Ma'am has obtained 1 patent and filed 4 additional patents reflecting her innovative contribution to this field. Her research interest includes deep learning, machine learning, and high-performance computing. Dr. Usha Devi Ma'am has 14 years of teaching experience and currently working as assistant professor in the Department of CSE, University College of Engineering, JNTU, Kakinada. With such an impressive background and extensive expertise, we are truly honored to have Dr. Usha Devi Ma'am with us today. Without any delay, now I invite Dr. SSN Usha Devi Ma'am to take over the session. Thank you all. Over to you, ma'am.
Thank you, madam, for your nice introduction. Shall I share the presentation now, sir?
Yes, madam. Yes, madam. Thank you, madam.
కెమెరా ఆన్ చేయండి.
కెమెరా ఆన్ చేస్తుంది, నాకు లైట్ మరి వీడియో స్టాప్ వస్తుంది.
కెమెరా అంటే అలౌ చేయండి. కెమెరా వెబెక్స్ లోనే జాయిన్ అవుతా.
వెబెక్సే.
Sir, are you able to see the presentation?
Yes, madam. Yes, madam.
నో కెమెరా వస్తుంది ఏంటి?
కెమెరా డిటెక్ట్ అవ్వలేదా?
ఎలా చేస్తాం దానికి? అది ఇంతకుముందు నా కెమెరా వచ్చింది, బాగా డిటెక్ట్ అవ్వలేదంటే ఏంటి అర్థం?
నేను అలౌట్ చేసి మళ్ళీ లాగిన్ చేస్తాను.
లాగౌట్ చేశాను, ఒకసారి ఆగండి.
సార్
లాగౌట్.
VCV Rao, sir.
Yes, sir.
Please mute, sir. Session started by Usha Devi madam. Please mute, sir. Now your voice is audible.
Is my voice is audible now? Okay.
Yes, madam.
Thank you.
It is audible.
So today I'm here to share my views and my thoughts about high performance computing. So previously I used to work on AI applications, different kinds of AI application, bioinformatics, time series analysis, stock market data, and so on. So at some point I feel that this is the end. It seems to be like that, because whatever is machine learning or deep learning models in general, how we are going to proceed. So we collect some data and then we divide the data into train and test in general classification models. So train and test, and then we start training the deep learning model, design a deep learning model or a machine learning model, then train the model with the data, and then go for the testing. Okay, the same procedure I'm following from several years, and training the data and doing the things. Okay, but what happens if the data is small? Then machine learning is suitable. So when we cross-check with a data just some 1,000 rows, 10,000 rows, then we select one machine learning model for the problem prediction, clustering, or anything. But when data is a huge, then we go for the deep learning. But nowadays, the data is generated continuously, and there is no end for this data generation. So you can observe in and around. So for example, the stock market data continuously every day it is going to be updated. For gold price data, every day it is going to be updated. So when we are dealing with the weather forecasting system, such a kind of systems, the sensories data continuously they are going to generate some data. So when the data is continuously generated and we have a lot of data to handle, but these kind of small models, these are not small models anyhow, these are powerful models only, but so we're unable to feed this big data to the small models, this kind of, even though they are powerful in identifying the patterns, so we are unable to push this kind of data to the machine learning or deep learning models. So for that, I found that this HPC as one solution actually. So in which we try to set up certain environment that handles the data in a parallel way, and then we can feed the data to the learning, any type of learning model that may not be any AI model, that can be any type of learning model. So this simplifies the total architecture and optimizes the performance. This is my idea about HPC actually. So before having the training in CDAC Pune, I used to work with AI. Later, I started working in a combination with HPC also. So this is the content that I would like to deliver in this session. So what is an SCT of HPC and architecture? Then what are the parallelism paradigms, and then programming models, and then HPC AI cloud combinations, and a case study on weather forecasting system. Then what are the challenges? So these are the things I would like to discuss. So this HPC is going to handle large data that are very complex and unmanageable using conventional approaches, and they're going to solve very high computational problems. This is the idea. So a standard computer system, for example, if you consider any of your laptop or a system or your system, it generally says i5 system, i4 system, i7 system, like that. So what is that 7 or 4 or 5 indicates? They indicate the cores in the system. So simultaneously how many tasks it is going to it can handle, that is the number of cores, right? So that's a basic definition. So here, suppose if I am using this presentation using the WebEx, am I really utilizing the computational power of my i5 core laptop? No, I'm not utilizing it. I'm simply open this WebEx and I'm using this presentation mode, and simply I'm delivering the lecture. I really don't know on which core it is executing actually. So even though there are 5 cores in my laptop, I don't know really what core is going to handle this particular application, these two particular WebEx as well as this presentations and all. So here it's an unknown thing actually for a normal user. But if you learn the HPC environments, it's going to be very well known. That means you yourself assigns the task to respect to core and make it work for you. So this is the idea. So in standard computing system, it solves problems in a serial fashion, whereas a HPC is a massively parallel computing, and it uses computer clusters, which are also called HPC clusters. And it is not a single component actually, it is a framework. We will have a lot of components actually behind this. So high performance components are also access to this HPC system. So this is the ENIAC system. That's a at that time it is having highest computation power. In 1947, we can observe a lot of vacuum tubes, resistors, and a lot of connections here and there. So this much big will be the ENIAC model. So top supercomputer speeds over years. So initially these are started with operations per second, then it continued with the floating point operation flops, floating point operations per second. Slowly it is reaching this particular moment, it is 10 power 18, I think 10 power 18, below 10 power 18. Okay, near to 10 power 18 we can say. So that many number of floating point operations can be performed nowadays. So that much speed they have. So this is the basic definition of flops. So these are etaflops, jet flops, e-flops. Whenever you are going to measure the performance of HPC, we generally the basic reference is this one only. The basic metric is flops, number of floating point operations per second. So the current top supercomputer in the world is Frontier with HPL result of 1102 petaflops. So this is installed at Oak Ridge National Laboratory, DOE, USA. So before going to this HPC, what is the structure of HPC? First of all, we will like to know what kind of problems we are going to face in every day. So in general, when we are doing the experimentation, initially there will be certain science, and based on the basic science, we do propose certain theory, and we test the theory with some hypothesis testing, and when we say okay, it's working better, no, we can add that science, that part to the science. So this is the old way. But later what happened? Theory, experiments, computation. So some certain type of high level computations are going to be done, then that is going to be added to the science. So now we have a computation science at the center, science, computer science, and mathematics. So computation science means the science that deals with high level computations rather than the conventional science when we say. So HPC in science has a lot of applications. You can see atmospheric science applications in climate and weather forecasting, air quality monitoring, the purity of air in a particular city, like that we can use a HPC for it. And earth science application, understanding physical properties of geological structures. Whenever we need to process large scale data, in that context we can go for HPC. So water resource modeling, seismic exploration, so space science, so life sciences, to process the genome sequences. So nuclear science, nuclear medicine for treatment of cancer, nanoscience, like that. There are multiple applications of HPC. And in HPC in engineering, you can observe aeronautics. So aeronautics, aerodynamics, applications in aeronautics and mechanical engineering, and a car crash simulation. That means up to what extent the car parts they can sustain for the pressure. So that can also be simulated. That means before that's like a stress testing. Okay. So it's a simulation model that we can do using HPC. Next, structural analysis. So civil engineering architecture also we can use is HPC. So behind this HPC, what we go for, actually that's a parallel computing. A large collection of processing elements that can communicate and cooperate to solve a large problems faster. For example, when we talk about divide and conquer approach, what we say that there will be a big problem. There is a theory like a big problem can be divided into some set of independent subproblems, and solving these independent subproblems and getting the final result, that complexity is going to, that computational complexity is going to be less than solving the main problem. So behind this, there is a theory. So here, a large collection of processing elements that can communicate and cooperate to solve large problem faster. So that is called parallel computing. Let us see the parallel computing basics. So large problems can often be divided into smaller number of units, and parallel processing means solving a task by making simultaneous use of multiple processing elements. If they are heterogeneous, that is a distributed computing. So here, what is this high performance computing? It makes use of parallel processing for running advanced applications, and also it has set of computing technologies. I told you already that HPC is not only something programming or something hardware. Okay, it's having a set of frameworks. It's a framework. So soon we're going to see what are the components in the HPC technology. So it is a set of computing technologies for very fast numeric calculations. So it is very useful for specialized application. And one more thing is, for not every application we can apply this HPC. Only for the tasks that are highly computational, and there can be, that means the task, if the program or process can be divided into set of independent tasks, then only we go for the HPC. If suppose if the problem or program that contains set of dependent task, then we don't go for HPC, because we cannot parallelize it. For example, in Java language, we create threads only when they are divisible units. Otherwise, we don't go for threads. Of course, the thread concept is nowhere suitable here. I'm just telling that. So whenever there is a possibility of dividing the problem into subproblems which are individual, that can be run in parallel, so then only we go for the HPC. So uses computer power to execute a few applications extremely faster, and a supercomputer is a system that performs in a highly effective way with a faster speed. So components of clusters. So now only we have seen, right? So HPC consists of a lot of things. So here is a thing. So login node that submits the your work, that submits your HPC program to the HPC system. And here networking gateway, local network, and switch fabric to maintain the networks, and accelerated compute nodes for highly computational tasks, and compute nodes for normal processing power, that has normal processing power like CPUs. And you can see GPUs and TPUs in accelerated computer nodes. So nowadays we started working with this GPU and TPU because of this Google Colab is providing one kind of one kind of feature to run your program faster. Those are accelerated tensor accelerated computing node. Next, computing nodes are normal CPUs, and storage acceleration. High level storage devices are required, and parallel file system should be there to handle with this HPC system. So this is the framework for HPC. Of course, you might feel that if this is the system, how we can establish all these things. So you, in general, when you are a software you are a software engineer or any programmer, then you can simply utilize the service of this framework by creating one NSM account. You can just simply submit your job to the login node. So login, then it is going to take care of your program, and it is going to run on HPC system. So you don't need to establish everything what is shown here. If you want your own system, then you need to go for this that establishment. So HPC is not a simple one component or one programming language, one model. So it is going to be like a stack. See, operating system. So we need to fix the operating system. So here it is an example, Linux. So middleware applications are also there. Slum is a scheduler that gives a slot to your job. So whenever there are multiple, see, if there is a HPC system, only one process one job is not going to be assigned to that HPC system, right? There will be multiple jobs in the queue. So how to handle these multiple jobs? Which processor is free to assign? So that kind of thing is going to be taken care by the Slum scheduler. So HPC programming tools are also available, and here there is one programming tool model called OpenMPI, which we are going to see in the next slides. So components of supercomputers, we have already seen this one. So you can observe this rack mountable server type of thing. Actually, this is like a supercomputer only. Okay, so there will be a lot of racks like this. So within the racks, we have this kind of elements. So I'm skipping certain hardware data so that I can discuss the programming part. So we can see the advantage of parallel computing. They overcome the limitations of normal CPU system. They run faster. They can handle huge data. So they save the time and they can solve the bigger problems. So making use of HPC, how to make use of HPC? Develop HPC aware software, designing parallel algorithms, writing parallel codes, make use of parallel programming frameworks, and use any open source applications. Use of available applications and workflows in open source or proprietary. So we are also going to see certain programming models and how to develop a small HPC application, small parallel application. So in ideal situation, each processor has a unique work to do in general. So communication among the processors is largely unnecessary. All processors do equal work. But whereas a parallel algorithm parallelism, there are 4 types of parallelisms: phase parallelism, divide and conquer, pipeline, and process form. So in phase parallelism, here, so this is going to be, the result of this is going to be synchronized here in this interaction, and again similarly, so all codes are going to work and the result is going to be synchronized in this part. Okay, they may either go for barrier or blocking communications. So in case of divide and conquer, we already familiar with this kind of structure. In general, when we deal with any kind of recursive algorithms, we generally go for this, right? One main function calls subfunction and subfunction returns certain value. So in similar way here, a parent process is divided into different creates child process, and child process is going to complete the work, and further it may create some more childs. Here, pipeline, data stream pipeline parallelism is also available, where each instruction is going to be at one particular state within the pipeline. So in this way also we can create the parallelism. So these all parallelisms, I think we can computer organization basics, we can see all these parallelisms. These are not something different actually. So similarly, process form model is a master and slave type of circuit. Here, master is going to allot the jobs to the workers, and workers will continue the job, and they will return to the master. So the coordination and control is going to be with the master. Desirable attributes for the parallel algorithms. So concurrency, scalability, data locality, and modularity. So these are the 4 important components. These are desirable attributes for the parallel algorithms. That means even though we increase the number of processes, it should work, and the memory should be accessible, and they should be parallelizable. They should work simultaneously. So decomposition should be possible among the work components. If suppose the work is not work cannot be divided into further, then this is not going to happen, right? The parent should create one child and should assign work, and here also the child is creating one more child and it's assigning some work. So they should be individual components, and first of all decompositional. Writing parallel codes. So there are many ways: distribute the data to memories, distribute the code to the process, then organize the workflow. The third step is organize the workflow, then optimize the resource requirement. So initially we need to distribute the data to the memories to initiate the work. So there are multiple parallel programming models: OpenMP, MP, and OpenAC. So let's go into let's go and see what are these models. So introduction to parallel programming. So OpenMP components. Let us see OpenMP components. First of all, so what is this parallel programming? So in serial computing, we have a program, and program is going to have a several instructions. For example, a C program has several instructions, and each instruction is going to be executed in a serial fashion, sent to the processor like the serial fashion. Of course, even it is a recursive function or a loop or any branching statements are there, it follows only serial computing. So next here, the program. Here in parallel computing, the program is divided into some sub-programs. Am I audible, sir?
Audible, madam. Audible,
Okay, sir.
madam. No problem.
So program is divided into some sub-programs, and those sub-programs are allotted to the processors. So in this way, the parallel computing happens. So what is the need of the parallel programming? So to handle the complex task, because here the total task cannot be given to one single processor to this one single processor, it cannot handle the larger task. So we need to divide it into multiple so that they are going to be manageable tasks. And improved performance, they can be completed in short span because every core is going to share the work. So better resource utilization, we have multiple number of cores, we can utilize all those cores for the work. But now we are not doing that, right? We are in ideal case, we are not doing that. We are not assigning at a particular job to a particular core. Actually, we are not doing any programming for that. We are simply utilizing all the devices like that, without knowing what core is executing what job. But here in this programming model, we can allot the process to the respective core, allot a job to the respective core. Next is scalability, and it saves time, saves money also. So problem decomposition can be done either through task parallelism or data parallelism, and task interaction can be possible using the shared memory concept or message passing. Let us see what are those concepts first. So shared memory, distributed memory. So here OpenMP, I have told you two programming language models, right? OpenMP and MPA. So in OpenMP, it is a shared memory concept. Sir, is the slide is visible? OpenMP and the MPA?
Yes, ma'am.
Getting some message actually, that's fine. Okay.
Yes, ma'am. Visible.
Okay, visible. Okay. Thank you, sir.
Shared memory.
Okay. So in OpenMP, it's a shared memory concept. So memory is available to all the processors, and all the CPU is going to get the memory from the centralized one. But in message passing interface, the memory is available to each and every. That means its own memory is available for every CPU. So they are going to communicate with each other through some network. So that is message passing interface. It's a difference between the OpenMP and the MPA programming models. So I'm skipping the process and threads part because we all are aware of the process is a program under execution. A thread is a lightweight process. So I'm skipping that part, and I would like to show you this OpenMP model, the basic syntax. So basic syntax is here we need to include this. This is a C. In C we can implement this OpenMP program. So OpenMP omp.h is a header file name. Hash include omp.h, and the construct is hash pragma omp construct. So what is this construct? There are multiple constructs are available here that provided by this OpenMP. Let us see, there is one construct parallel num underscore threads. Okay, so here parallel, that means these threads, this parallel is going to tell that this is a parallel region. This is a parallel region. So if I wrote parallel here, it means it's a parallel region. So in main void printf hello world, it is going in just a general C program that is going to return hello world, right? Hello world. So here, suppose the same type of program, if I wrote in the OpenMP, so initially that stdio.h is common, and then omp.h include the OpenMP header file. Then int main void and then hash pragma saying that it is a parallel region OMP parallel. Okay, within this parallel region, we need to write what is the task. We need to define the task that should be parallelized. Suppose if we don't have any parallelizable task, then we cannot go for any programming language model. Okay, so that means a major thing in HPC, suppose if you want to implement any parallelism, you need to understand and analyze the problem very deeply and identify the parallelizable modules first. So then only you can apply this OpenMP or MPA language models for that to optimize the performance. So that kind of analysis is very much required. So here for example only I'm taking here. So int id equal to OMP underscore get underscore thread underscore num. So this is a runtime library function that is going to give the thread, return a thread ID. So it returns a thread ID to this int ID. That means for every iteration, it's going to take one ID value and then it prints. But how many times it is going to run? I didn't specify any kind of construct here. So how many times it is going to specify? By default, it is going to take one value 32. Sometimes it may also, for some other person, it may take 64 also. Some other run, it may take some other value, 32, some 16 like that. Okay, it depends on the, it depends. Okay. Of course, I will tell you how to assign that value also. For example, if TID is 0, for that, and what is this TID? This TID is a unique thread value. It's a private to the thread also. It's a unique value. So no two threads are going to have the same type of ID. So thread ID is 0. It prints hello world thread 0, hello world %d. This is ID. So whatever is the ID assigned to this ID variable, so that will be printed here. So initially, suppose if thread ID is 2, it prints hello world 2. If thread ID is 3, it prints hello world 3. So like that, it is going to display. And you might think that they should be in order, like 0 thread, 1 thread, 2 thread, 3 thread. But actually, they won't go in order, because these whenever it is available, when the thread is available, it is going to assign the task. So sometimes 3 is available, sometimes 1 is available. So in next iteration, here we got 3, 0, 1 to next iteration, you may get 0, 1 to 3 also. So it's not a unique thing. So this example just is used to demonstrate the structure of the program. It's not having any purpose actually here. So just to understand the structure of the program. Anyhow, it's going to display for display different elements for different iterations. It may not be any unique thing. Here the point is, suppose if the number of threads are 4, then it will be the output. So how to give the number of threads 4? So in shell, again we need to open a shell and we need to give the export open num threads equal to 4. Or else in here also in the program we can give a constant value 4. Or else we can give the export open num threads equal to 4. So it is going to set the number of threads equal to 4. Then this will be the output. So how to run this program? So using GCC compiler, GCC-f openmp hello world.c hello. So this hello is the output file. So if you display the content of this hello, you will get this hello world. So suppose that if you are using this Intel compiler, then you need to go for ICC. So ICC command. So OpenMP components are parallel region constructs and data scoping variables, work sharing constructs. So environmental variables, synchronization, runtime libraries. So there are many features it is going to provide actually. So we have seen the parallel region part only. And one runtime environment, number of threads. So this point only we have seen. So to allow runtime system to determine the number of threads, export open dynamic equal to true. So to all nesting of Parallelisian, open nested true. So these are the environments. Next, what is this OpenMP? Finally, it's a powerful tool for parallelizing applications. Of course, we have not discussed anything deep about OpenMP. So I have given you that this is the structure of OpenMP and these are the possible features. These are the features of OpenMP. And with that, we can say that it's a powerful tool for parallelism because it is having all the facilities that are required for parallel computations, nested parallelism, scheduler, and thread limit, wall clock timer, team size, nesting level, and scheduling type also we can decide. The job scheduling type also we can decide. Dynamic threading also this can be decided. It also handles the errors. So with these features, so these are the useful features for parallel programming. So it is easy to learn when compared with other languages, and so it's having the basic constraints, parallelism, work sharing constraints, and synchronization constraints. So we can use this kind of OpenMP programming module in any kind of application. But we observed that it's following the concept of shared memory. So we have seen that, right? So this is one programming model we have seen, and second one is message passing interface, where we follow this MPA, message passing interface, where every CPU is going to have its own memory and it passes the information to the other node, but through some network. So this is the thing we are going to see. Let us see this one. So a serial code is going to look like this. Just simply rank equal to 0 means it is a process number. 0 is the parent process ID. So size equal to 1, there is only one process. I hope you are able to see the screen. So printf hello world, I am process %d of %d. That means rank and size. Here we are following on serial kind of fashion, right? In serial code, there will be only one process that is going to be the parent process. It simply displays the hello world, I am process 0 of 1. Okay. So this 0 represents the rank. Rank means here the process ID. Size means number of process. But this is the, suppose if it is a parallel code, then this is somewhat different when compared with OpenMP. So in MPA, so there will be steps like initialization MPA. You can see the font, blue color font, initialize MPA, get the rank of the current process, get the total number of process, then print the respective thing. Okay, and finalize MPA. So these are the crucial steps in MPA model. So how to initialize? So here, this is a structure. First of all, we need to include the MPA header file. MPA header file, MPA init, MPA underscore int arguments, and this is structure of taking the arguments. And then MPA communicator rank, MPA communicator world consists of all the process here. And here the rank represents the current process rank, current process ID. And here the size means all number of process, the total number of process. So printf hello, I am process of so and so, rank of so and so. So then finalize. Okay. So it is going to display hello world, I am process 2 of 4. I told you already. So it is not going to start with 0. So it will start with some value. Whenever that process is run, that is going to be, that core is free, that process got run. So it just simply displays I am process 2 of 4, 3 of 4, and so on. So the same thing here explained. Now I would like to show one more example. One more example here. So this is very important because we have, what is this MPA, message passing interface? So there will be one sender and receiver. They need to communicate through message passing. So here, this is common. MPA underscore init is common, communicator size is common, communicator rank is common, everything is common. But here, if process rank is 0, that is a parent process, then message item is equal to 42. Now we are interested to send this message item 42 from parent to some node, some other process rank, that is equal to 1. So 0 to 1 communication. We decided to send this 42 to process rank 1. So how to send it? So for that, we need to use this MPA send message. So the syntax is shown here. What is the message? And then this data type, integer. And then here this 1 represents that it's a process rank 1, that is a receiver. And this one is, what is it? Tag. So this tag should match. For example, this tag can be 100 here, 100. This tag can be changed to 100. Here also we need to change it as 100. That means on common tag, they are going to communicate. Okay, the tag should match, then they will communicate. Okay, if the process rank is 1, then only it is going to receive this information, message item 42. So now if I display this value, message item, so I will get 42. So message sent 42, rank is 0, because here the rank is also represented. So message received 42, rank is 1. So from 0 to 1, 0 process is communicating with the process 1 by sending that message 42. So there are many more companies that are using this HPC. So these are the companies. Few companies I'm listing. So IBM Corporation, Intel Corporation, Microsoft Corporation, Dell, the Hewlett Packard Enterprises. So NSM India initiative, I would like to share this initiative also, about this initiative also. So National Supercomputing Mission is it started in 2015, I think 2015. Yes, it's continuing, and its aim is to give awareness on HPC and encourage researchers on HPC. So that our India is going to become a self-resilient about this technology HPC. Sir, shall I continue for 10 more minutes?
Yes, 10 minutes. Thank you.
10 minutes. Okay, sir. Thank you, sir.
Yes, thank you.
10 minutes. So there are different developing environments are there. C++, C, Fortran, Python, and so on. And there are compilers like GCC. Previously, we have seen how to execute the program, run the program using GCC compiler. So these are various compilers you can use. And these are the parallel program modules. We have seen message passing interface in OpenMP. And in the next session on Thursday, I'm going to tell you this CUDA programming also. So these are the job schedulers, the slum. The major objective of the slum is to optimize the scheduling, workload balancing. For example, if everybody pushes their jobs into the queue, they don't that means fully engaged. These computational sources are going to be fully engaged if they're unable to manage these workloads. So which are high priority, which are low priority, like that. So that's why slum should be there. So using Python also, we can implement OpenMP programs. So for that, we need to use a NumPy package. From NumPy, we need to import the NJIT and the prange. So these libraries are very much intended to use for OpenMP programming. So here NJIT parallel true enables parallelization using NumPy. Okay. So the structure is not that much similar, but it is somewhat simpler only. You can practice. So definition of parallel sum array total equal to 0 for I in prange length of array. That means it's just parallelizing the loop using prange. So here we are just computing some arrays, processing some certain values, and the total of those array elements. This is a parallelism now. So what the array contains? The array consists of random numbers, 1000. Okay. So some generates 1000 random numbers. All those random numbers are going to be summed up in total. So computing sum using parallel sum, result equal to parallel sum. So what is this parallel sum contains? Simply, it is in the part of this NJAT parallel true, right? Enable parallelization using NUMBA. So here in this part, it's going to parallelize the computation. Similarly, MPA programs can also be performed using Python programming. So for that, you need to import MPA 4Py run. So this COM world, rank, size, everything is the nomenclature wise, it is same. Here also the nomenclature wise, it is same. Okay, only the structure wise, there is a little bit difference. But you can practice these things in any Python compilers or Python interpreters. So I would like to go through a weather forecasting case study, because I have seen a Microsoft video released by Microsoft saying that they have achieved a better weather forecasting model with 40,000 cores. That means using HPC and AI, because for prediction they need AI. For maintaining this much huge data, they require HPC also. So they have used 40,000 cores to achieve the better performance in weather forecasting system. So for that, the HPC infrastructure for simulation needs to be set up for weather model simulation, optimization, cluster setup, and then AI model for the collected data processing, pre-processing, the machine learning models or deep learning models, and hybrid numerical weather prediction. NWP means numerical weather prediction model plus AI system. And it should be a real-time learning, because continuously the data is going to be generated and continuously it is going to predict the weather. So there are a lot of softwares and tools. Already we have seen software stack, the same thing I'm going to explain. But in previously I have not discussed this Python models. Actually, in PyTorch also we can go for the HPC. So you can implement the OpenMP MPA using PyTorch. And next, visualization. That means for this particular weather forecasting system, what are the required things? HPC required things, then AI required things, then software HPC framework required things, and weather models and AI framework required things. Then what are the environments that we need to use for this weather forecasting? Then for visualization, what are the things available? So there are a lot of challenges that we can observe: scalability and accuracy, real-time processing, resource management. Of course, there are certain methodologies evolving to handle all these challenges. And I would like to cover the combination of this HPC as well as AI. So nowadays, we already saw that AI is having good power for the prediction modeling. But HPC support is very much required to handle huge set of data. Otherwise, even the AI is having power with that much computational complexity and that much slow running, it may not be useful if you use this AI alone. So we need to go for AI and HPC to process large sets of data. And one more thing I would like to share here is, every time, so we don't have the setup to run the total HPC system. So hence industry is also depending upon this HPC cloud resources. So HPC cloud is also very helpful. Instead of putting a lot of efforts and cost on the framework of HPC, they're simply going for HPC cloud. For example, this IBM cloud, HPC can help organizations flexibility manage compute intensive workloads on premises. So because of this IBM cloud, it becomes very manageable. So these are the references I have used for my presentation. So AICTE Sankal program, I'm very much thankful to the CDAC Pune people for training me on this HPC high performance computing system, and so that content I have used here for the presentation, and also I have used some notes from the IBM. So these are the references. This is the disclaimer.
Thank you, madam. Thank you
Thank
very
you.
much for your wonderful session. Participants, if you have any doubts or any queries regarding the session 1 on fundamentals of HPC, please directly ask madam or post in the WhatsApp chat box. I verified no queries asked till now. So during the session, if anyone has any query, please post in the chat box, and at the end or middle of the convenient of the resource person, we will answer the queries. Is there any questions from audience? Okay, this program is delayed. Thank you, madam. Thank you very much.
Yes, sir.
for your
Thank you, sir.
Wonderful
Thank you,
presentation.
sir, for giving me this opportunity. I'm very happy to be part of this one. Thank you so much.
Thank you, madam. Thank you for your wonderful lecture and presentation on fundamentals of HPC, which covers the overall from OpenMP to applications to overall AI tools to the cloud and agility things. And thank you very much. And we are waiting for next session. Dr. VCV Rao sir. I request our coordinator, Mr. V. Anurag, to give